Starting with number 1, part D, it says solve and express your answer in interval notation. So this one has no x's in a denominator, but it is a polynomial. Because there are 4 terms on this side right here, we need to try to factor by grouping. So I can pull an x squared out of the first pair. That would leave me with x minus 3. The second pair, we can factor out a negative 9. And that would also then turn that into x minus 3. And then I have my less than or equal to 0. The x minus 3's match. And then I have an x squared minus 9 as the leftovers in front of each part. And then that does factor one more step. So because these two are perfect squares and that's a minus, we get an x plus 3 and an x minus 3. Now, anytime you have a quadratic or bigger, so x squared or higher, in an inequality, inequality is the key word here, you need to use the chart method to figure out where the interval notation is going to exist. So we have to set these in equal to 0 to figure out what the crucial critical values are. That's what they're called. These are places where we could equal 0. Now, 2 of them are identical, so we don't need to solve that twice. So it looks like my critical values are 3 and negative 3. So once you have your critical values, you place them on your chart, which is a number line, from least to greatest. Because these are both things that were on top, we don't need to do anything like have an open circle because of the denominator. We'll talk about that in a minute with this one. But because this is closed, these are both going to be closed because of the equal to. So this would be negative infinity to negative 3 with a bracket, and negative 3 to 3, both with brackets, and then 3 to infinity. What we've just done is we listed this out as interval notation based on where those critical values are. You then pick a test value that has to exist in each region. So something smaller than negative 3, since this is to the left, so I would use negative 4. Something between negative 3 and 3, I would use 0. Something bigger than 3, I would use 4. You then write all 3 of your factors. Even though these are repeats, they each affect the sign. So x minus 3, x plus 3, x minus 3. And we hope that we end up being less than or equal to 0, which means our final answer needs to be negative. So when we test these out, negative 4 minus 3 is negative 7. Negative 4 plus 3 is negative 1. Negative 4 minus 3 is negative 7. We only care what the sign is. If we multiply those 3 negatives together, it comes out negative. 0 minus 3 is negative. 0 plus 3 is positive. 0 minus 3 is negative. 2 negatives multiplied together make a positive. 4 minus 3 is positive. 4 plus 3 is positive. 4 minus 3 is positive. So that's 3 positives, which will stay positive. Now, that means that since we're looking for negatives, this region right here is good because we get a minus sign there. Anytime you have a closed circles are also solutions because of the equal to. So notice that this guy is okay because he's included with this interval. But this one needs to still be included in our answer, but it's just going to be a singular point. So there will be a single point here that works even though there's 2 pluses on either side of it. So the way we write our answer is negative infinity to negative 3 with a bracket, union. Anytime you have a singular point, you put it in a little set, which means it's not an interval, it's just a single number. Now, we usually don't give you this variation on the test because that's not something that typically happens. Ours on the test are pretty straightforward. You get just intervals that work, and usually the endpoint's already included as part of that interval. But that's how you would handle that case. So any questions on that one, or do we feel okay? Okay, looks like most people are saying we're good. If you're not responding, I'm assuming that means you're good as well. So make sure you're letting me know if you're not. You don't need to copy these as we go because remember I'm going to post them after we're done right away as a PDF. So you'll be able to access those immediately. So we're going to do E next. And periodically I am going to save this. Otherwise I will not have, it'll die on me sometime and then I won't have all the writing. So let's look at this second one. This is also an inequality, and it's going to require the chart method because it's something that's not just x to the first power. There's two x's on both top and bottom. With the fractional ones, you want to get everything on one side. So we want to move over that positive 3 by subtracting it. I go ahead and put it over 1 so that I can see my two different fractions that I'm trying to subtract. The next step, usually after moving something over, is creating a common denominator. So if I multiply this one by 2x plus 3 on top and bottom, that will then create a common denominator for those two fractions. So this would be 4x minus 1. Be careful right here. This is a negative 3 that is getting distributed to both of these. So that would be minus 6x and minus 9 all over 2x plus 3 greater than or equal to 0. If we combine like terms on top, we get negative 2x minus 10 over 2x plus 3 greater than or equal to 0. So when you're dealing with the ones where you have a denominator and a numerator, you break your critical values into two pieces, what comes from the top and what comes from the bottom. So we set the top equal to 0 to see what that critical value would be. So I would add 10 over and then divide by negative 2. So it looks like my top critical value is negative 5. For the bottom, I set the 2x plus 3 equal to 0 to see what that critical value would be. Subtract the 3 over, divide by 2. So it looks like negative 3/2 is my critical value for the bottom. Anytime you're doing a fractional inequality, the top obeys the symbol. So if this has an equal to, this would be closed. If this does not have an equal to, this would be open. So the top obeys that symbol. It's okay for a top to equal 0. The bottom is always open. Doesn't matter if there's an equal to or not. If you say equal to 0, then you're getting an undefined denominator. So we always leave the bottom open. So usually when you're doing these fractional ones, especially if there's an equal to sign, you're going to get one circle or two circles that are either open and a closed circle. So we place these on the number line from least to greatest, and I am sorry about my voice. Battling allergies pretty bad. So negative 5 is closed. Negative 3/2 is open. So then I'd write my intervals, negative infinity to negative 5 with a bracket. Negative 5 to negative 3/2, bracket on the left, parentheses on the right, and negative 3/2 with a parentheses to positive infinity. Same thing we just did a minute ago. We pick a test value for each region. Less than negative 5. Make sure you don't use negative 4. Negative 4 is bigger than negative 5. So you need to go to the left on the number line. So I'm going to use negative 6. This is about negative 1.5. Negative 3/2 is about that. So I need something between those two. I'm just going to make my life simple. I'm going to use negative 2. And then something bigger than negative 1.5. Since 0 is bigger, I'm going to use 0. 0 is easy to plug in. As long as the number you pick is in this interval above it, it's going to give you the right answers. And then we put our two factors down. The top is negative 2x minus 10. The bottom is 2x plus 3. And we hope that it comes out greater than or equal to 0 because that's what this says. So that means we're looking for positive numbers at the end. So when you have a negative out front, it's a little bit more difficult. You need to make sure you watch your signs when you multiply. So negative 2 times negative 6 would be positive 12. Minus 10 would be positive 2. Negative 6 times 2 would be negative 12. Plus 3 would be negative 9. A positive and a negative either multiplied or divided together, since the rules are the same, is a negative overall. Okay, so -2 now is going to go into both of them. -2 times -2 would be +4. 4 minus 10 would be -6. -2 times 2 would be -4. Plus 3 would be -1. Two negatives put together makes a positive when you multiply or divide. 0 is easy because it's just the constants, so that's -10 and +3, and that makes an overall negative sign. So since we only wanted greater than or equal to 0, we're going with this middle region, the plus. So that means this interval up here is the final answer. So -5 to -3/2. And make sure you have your bracket and parentheses correct like you did above. Are we okay on this one, or any questions? Are you guys good? Okay, so let me scroll down. The next question you guys had put on my list is 2C. I've already had space. So this is an absolute value inequality. This was in section 2.6. The first thing you have to do with an absolute value inequality is isolate the absolute value on one side. So my first step would be to move this 10 over by subtracting it. So that makes that 5 absolute value of 2x minus 4, close the absolute value, less than or equal to -4. And then we also need to get rid of that 5 that's out front by dividing it over. So I have absolute value of 2x minus 4 is less than or equal to -4/5. So with these, if it ever has a negative after you've isolated it on the other side, it's either going to be no solution or all real numbers. You do not need to solve any process after this point, so you don't have any specific way to set it up. What you have to think about is, what is an absolute value? An absolute value is always going to come out positive after you plug something in and take the absolute value. So the question is, can a positive ever be less than a negative? So that doesn't make sense to me, because positive numbers are always bigger or to the right. So if it's a less than after you've isolated, with this being an absolute value, and there's a negative on the other side, there is no other steps. It's just no solution. There's not a single number on the number line that could plug in and make this come out true. Now, if that had been a greater than or equal to, or just a greater than symbol, a positive is always greater than a negative. So that would have been all real numbers. So if you have an absolute value and there's a negative on the other side, you just have to ask this question, because absolute values always end up positive. Is a positive whatever this is, and then ask the negative. If it makes sense, it would be always. If it doesn't, it would be no solution. Is that one okay? We okay, everybody? All right. Some of you are responding. Remember, if you're not responding to me, I'm assuming you're good. So let's move on down to the next one. And before I forget, I'm going to save, because if I don't, I will lose work. So let me do that real quick. So the next one that you guys had on the list, in fact, this was one that was emailed to me before our class session tonight started, was 8B. It was a graphing of a parabola one. So when we look at this, we have graphed the following equation by finding the direction of the parabola, opening, which means either up or down, the vertex, any intercepts, and the axis of symmetry. So this is the one we had, remember, in class, where I said on the test there'll be some blanks for you to fill in. Obviously, I didn't want to waste a lot of room with that on this. X-intercepts, Y-intercept, and then axis of symmetry. So, and then we have to graph it usually afterwards. So to know if it opens up or down, you just have to look at the leading coefficient. If it's negative, it goes down like a frown. And if it's positive, it goes up like a smile. So since this is positive, this would open up, which means at the end, my parabola should look like that. The vertex, remember, there are multiple ways to find the vertex. You could go to transforming it to vertex form, but we said for graphing purposes, it's easier to do the x equals negative b over 2a. So that's how we find our vertex. So this would be negative 10 over 2 times a, which is 2. So that's positive 10 over 4, which reduces down to 5/2. So the vertex starts off with 5/2 as its x. Then we plug that back in to find our y value. Now this one's not pretty because it's a fraction, but we square the top and bottom. So that would be 2, and then that's 25 over 4. I can multiply negative 10 times 5 since those are both top numbers. So that'd be negative 50 over 2. I'm going to go ahead and make 12 over 1. I need to multiply 2. Actually, no, I could just reduce this. I could reduce that with that, and that would just be a 2 on the bottom. So then that would be 25 over 2 plus, excuse me, minus, lost my sign, minus 50 over 2. Doesn't want to delete that plus sign. Minus. And then plus, let's go ahead and get the common denominator here. So that'd be 24 over 2. So 25 minus 50 would be negative 25, and then plus that would be negative 1/2. So this is not going to be a pretty one to graph, but at least we know what the vertex is. The x-intercepts you find by setting the whole thing equal to 0. So this is to find your x-intercepts. If it was me, I would probably divide everything by 2 to get rid of that 2 in front because they're all even. So that would be x squared minus 5x plus 6. And notice I also divided 0 by 2, but it's still 0. And then that factors into signs need to be the same and add to negative 5. So that'd be negative 2 and negative 3. And that gives me an x-intercept of 2 and an x-intercept of 3. So 2, 0, and 3, 0. The y-intercept is easy if you're in standard form. It's just the last number, because if you make all the x's 0, everything else goes away. So that would just be 0, 12. The axis of symmetry is always the x part of your vertex. So x equals that. So if I go to graph this real quick, I'm obviously not going to graph that y-intercept since it's pretty large, but I'll graph all of the other points. So 5/2 is about 2.5 and then down a half. So there's that point. That's my vertex. 2 and 3 are both my x-intercepts. So this is a very skinny parabola. Notice that those are very close to that vertex. And it's going to go way up here to 12 before it actually crosses the y-axis. And that's all I need to do. So there's all of my pieces you would be asked to do on the exam portions plus the graph. Is everybody okay with 8B? Okay. Let's move on down to 9. I had a question, I think it was about 9A. If my computer won't lock up, don't lock up. There we go. I'm going to give myself a little bit more room on this one. 9A, you have to do all 6 of these function operations up here. So the first thing we need to do is add the 2 functions together. So we write 2x over x minus 7 plus 5 over 4x. We're going to need a common denominator because you can add fractions if you have a common denominator. So it looks like this side is missing the x minus 7 and this side is missing the 4x. So if we work that out, that would be 2x times 4x is 8x squared. I do need to distribute the positive 5 to this, so that'd be positive 5x and minus 35 all over 4x and x minus 7. Now, I don't have my answer key out, but normally you would still have to check to see if this factors. So let's see, 8 times 35 is 280. If it's going to factor at all, it would have to be a factor of 7. So I'm just going to play trial and error for a second instead of doing factor by grouping. If this was x minus 7, the only way that could factor is if this was an 8x and this was a 5, and since this is a negative, they have to be opposite signs, and that's not going to factor into that's not going to FOIL back to this. So because the only thing that could possibly cancel or even help me would be an x minus 7, I went ahead and just played with that to see what would the factors need to be, but it doesn't look like it's going to factor, so I'm not going to waste the time of doing the factor by grouping. It doesn't help. So even if this did factor, it's not going to factor into anything that's going to cancel that. So that would be my final answer format for the plus. So next we would want to do the minus. And again, I'm okay if you leave the top unfactored as long as there's no factors that would cancel out with the bottom. And then, so this time we're going to be subtracting. So essentially you're doing the same thing, except you write a minus in between them. So notice I'm just rewriting these tops, but with a minus in the middle. So this would be 8x squared minus 5x and plus 35. And I don't believe this one factors into anything helpful either. It's still going to be 280. And it would still have to be an x minus 7 in the bottom. Yeah, that's not to make a cancel, so that's not going to help if I tried to factor it. Numbers that we give you on the test are usually much smaller than these, so it should be easy to determine if it factors or not a lot quicker, instead of going through all the factor by grouping steps to see if it does. If we do f times g, that's actually really easy with two fractions. You just write the first fraction times the second fraction. We can cancel out an x in these two monomials, and we can also reduce the 2 and the 4. That's only legal because those are both monomials. That's why we can individually cancel them. So then 1 times 5 would just be 5, and then you can either distribute this or leave it unfactored. Either way is acceptable. So 5 over 2 parentheses x minus 7. The next one is division. So we stack these as 2x over x minus 7 all over 5 over 4x. This would be 2x over x minus 7 times 4x over 5. Now I don't have anything to cross cancel because 2 and 5 don't have anything in common. So I just go ahead and multiply. This would be 8x squared over 5 parentheses x minus 7. So there's the division step. The last two listed up here in the directions are f of g and then g of f, so they're compositions. So if we do f of g, remember you write the f function as an empty shell. So f of g of x. So you come up here and you read this as 2 blank over blank minus 7. The blank, remember, is going to be g of x. So that's why I'm going to fill into those two spots. My g of x was 5 over 4x. And I'll move this down so you can see it a little bit better. Now, anytime I'm dealing with the fractions inside of fractions, if it was me, I'd probably clean this up first by multiplying that 2 and 5 together, since that's like a 2 over 1. So this would be 10 over 4x over 5 over 4x minus 7. If you multiply everything on top and bottom by 4x, that will clear out those little fractions. So this would be a 10 on the top, 5, and then you do have to multiply this out since there's no 4x to cancel. So that'd be minus 28x. Now notice in the directions above, they didn't ask us for domain on any of these, so you don't have to go through the steps of finding that domain process on this one. And then the last one is g of f of x. So this time you write the g function, which was 5 over 4, and then blank for x. And in that blank, we fill in f of x. So the f of x was 2x over x minus 7. This one's a little bit easier to evaluate. We don't need to do anything with these little cross-canceling by LCD, because if you work that bottom out, that would be an 8x over an x minus 7. You can think of the top as being 5 over 1, so this is multiplying by the reciprocal. So 5 over 1 times the reciprocal of the bottom. So we get 5 parentheses x minus 7 over 1 times 8x would be 8x. So that is all of the different function evaluations for those operations. So you had adding, subtracting, which both required a common denominator. Multiplying just meant top times top, bottom times bottom. And division meant multiplying by the reciprocal, since these were both fractions. And then composition, both directions. So are we okay? I mean, I know that was a long one, but are we okay with that concept? Okay, let me go ahead and save this real quick since I did a lot of writing right there, and then we'll move down to our next question. All right, here we go. So the next one that I had a question about was 10a. When you're dealing with domain, because that's in the directions, remember we said that polynomials would be all real numbers. Absolute values are also all real numbers. And odd roots are all real numbers. The only things we've learned about so far that give us issues are even roots. Whatever's under that radical has to stay greater than or equal to 0. And then anytime we have a rational, which means we have something in our denominator, which means we can't equal 0 in our denominator. So pretty much the even roots and the rationals are the only ones so far in our universe that cause any issues. So since this is a cubed root, that falls under odd roots. You can plug anything you want into here. If it's negative underneath, so what? Odd roots, you can evaluate a negative. It's even roots that cannot have a negative underneath. So this is just understood to be negative infinity to infinity. So for A, there's not any work because it falls into one of those that has no restrictions. Is that okay for that one? So notice C would also be no work because it's an absolute value. And I did both B and D, I believe, on the, I know I did at least D, which is one I told them was more like what you should see on the test. I did D on the other video from last night, and it's on the PDF I posted as well. Okay, so let's look at number 12. This is the difference quotient. So notice that we have these two things we need to do on top. I always just split them up into separate things and evaluate them one at a time. So I do f of a plus h and go ahead and work that answer out using my function that they provided me with. And then I do negative f of a, which remember means -1 times f of a. So if I do this function with an a plus h going in for my letter x, this would be 5 parentheses a plus h squared and then -1. It's just like when we did composition, it's just a substitution. You need to then FOIL out that. You can't just square it because it's got a plus sign. So that would be a squared plus ah plus another ah, and h times h would be h squared. I would distribute my 5. And then I do have two like terms I can add together. So it looks like this one ends up being 5a squared plus 10ah plus 5h squared minus 1. So that right there is just that top portion, the first piece. So then I do negative f of a, which is -1 times f of a. So you go back to your function and you write a -1 and then a parentheses, and then you write this function, and instead of x, they want us to change it to an a. Marjorie had a question. She said, why did I not combine like terms before distributing the 5? Both methods work. You could combine ahead of time. So if you wanted to make this a 2ah first and then distribute 5, you're still going to get 10ah. So there's no real hard or fast rule that you have to do that first. I do find that sometimes students don't add those correctly, the AHs and the AHs, when there's a 1 in front of them. So sometimes distributing first will save them from making a mistake there. So it really doesn't matter though. So then with this one, we need to distribute that -1, so that makes it -5a squared and plus 1. So usually the second one is much easier. So this right here stands for this negative sign and that f of a up there. So once you have your yellow and your blue, because that's how I color coded them, you just place them on top from the order that they're here. So this would be 5a squared plus 10ah plus 5h squared minus 1. Then I bring the blue one up, minus 5a squared plus 1. Notice I don't worry about this negative because I already took care of it. And then this is over h. If you've done this correctly, some stuff should cancel. 5a squared with -5a squared and -1 and +1. So notice we get 10ah plus 5h squared over h, and then the h reduces on both of those. So I'm dividing both of them by h. So there is my final answer. So the hardest thing I think about this problem for students is doing this first evaluation correctly. Most people get this one. It's taking the time to FOIL this out and distribute it correctly. Or just making sure you plug it in correctly at all, because that can be a deal breaker if you don't plug it in correctly. So just taking the time to work through that part slowly. Do we feel okay on that one? All right, my next one in the questions was 14a. I think I got this question last night as well, but I'll go ahead and do it. The reason this one gave people not such a happy vibe was because you're having to turn this into vertex form, which means you have to complete the square. And we usually like completing the square as long as the middle number is even. I'm going to go ahead and tell you the one on the test has an even number in the middle. It may have something you have to factor out, but it does end up still with an even number in the middle. But this one's not horrible, it's just you have to deal with this being odd. So when we complete the square to go from standard form of a trinomial to vertex form, we first separate out the x terms And I always put a blank kind of to make a new trinomial from the constant. And remember, we called this last blank our counter, because whatever we add or subtract here, we do the opposite here to counter it as if we added 0. So since this has a 1 in front, we're ready to go straight into completing the square. To complete the square, you take half of the middle part of the trinomial and you square it. You do not want to turn that into 2.5. You want to leave it as a fraction. You just need to square both top and bottom. So that would be 25 over 4. So this would be x squared plus 5x plus 25 over 4 minus 8. And since there was no part out front, we really did add a 25 over 4. So the opposite of that would be to subtract a 25 over 4. What should happen right here is if you were to add the pieces together or work it all back out, it should go back to the original problem. The reason we do this is so that it'll factor into this x minus h part. So when you factor it, you always use what was the number right before you squared it. So this would be x plus 5/2, since that was a positive 5/2 squared, and then we need a common denominator for this. So negative 8 over 1 needs to be multiplied by 4 over 4. And then we have negative 25 over 4 to add to that. They're both negative, so we add and keep the sign. That would be negative 57 over 4. And again, you could use a calculator just as easily to do that. So that is the vertex formula. That's how that vertex form looks. It also says to state the vertex. If you've got it in vertex form, you should be able to pull the vertex directly off of this. You always do the opposite sign of what's inside the parentheses and the exact sign of what's at the end. So we don't have to graph this, but that's the vertex. Is that one okay for everybody? And like I said, we're nicer on the test. We give you something that has an even term in the middle so that you don't have to deal with a nasty fraction. Okay, so we're reaching close to the end of our list. I had a question for 15B and 16A, and then we'll be at the end of what you guys had requested. 15B is graphing a function and writing the description of the transformation. So you have to first note what is individually different about this function than the other ones. Notice this one has a squared. That means it's a parabola shape. This one's a cubed. That means our parent shape, because you do have to know your generic shape if you're going to try to do a transformation, is x cubed. If you don't remember what x cubed looks like, make a little table. Plug in -1, 0, and 1. -1 cubed is -1. 0 cubed is 0. +1 cubed is +1. And that will kind of help you remember what that shape looks like. Now remember, this is not a straight line. Straight lines do not have powers bigger than 1. This was that parabola-like shape, but half of it's up and half of it's down. So that's what x cubed looks like. So you have to know that part first, and that's based off of this having the cubed symbol. The transformations, remember, if there's something added or subtracted inside, it moves you either right or left. If there's something added or subtracted at the end, it moves you either up or down. A negative attached to an x inside flips you across the y-axis. A negative before the whole parentheses flips you over the x-axis. So when we do a shift, if it happens inside before cubing, it's what we call a horizontal shift. Horizontal shifts always do the opposite of what you think. So since this is a +2, we need to counter it and make it go back to 0 so that this would be 0 cubed. So that means we do left 2, which is like subtracting 2. This right here is a negative in front of the parent. That's when you reflect over the x-axis. In other words, all your y's flip-flop and change from positives to negatives. And all your negative y's will change back to positives. So it just flips all of the y signs. When you go to graph this, you need to do these in order from the order of operations. And what I mean by that is the thing that's closest to X, if you were to plug something in, you would add 2 before doing anything else. You'd do that before you even cubed it. So whatever's closest to X needs to be performed first. So when I go to graph this, so this would be my final answer. I always start with where did my original point of the center start, which was 0, 0, so I'm kind of, let me use a highlighter. Here is 0, 0. I'm supposed to go left 2, so now there's my new center right now, and then reflect over the x-axis. Well, you can't reflect over the x-axis because you are on the x-axis, so that's going to be my first point. That's this guy right here, the center point. I had a point at 1, 1. That was one of my points on my original parent. So here I am at 1, 1. Okay, so I go left 2. This can be reflected over the x-axis. It will reflect down into that spot. So notice that's my point that used to be right here. And then -1, -1 was my third point. So I'll do it in green. So I'm trying to kind of color code this so you can see where everything ended up moving. So there's that one. And then we'll do green for this one right here. So we start at -1, -1, and we go left 1, 2. If you reflect this over the x-axis, it goes back up. So it's a mirror image up here. And then we draw the cubic kind of shape. So this would be up first, hit the middle, and then down. And you're more than welcome to bring colored pencils to the test or whatever you need, but just make sure you can transpose those points one at a time. And don't forget, if you freak out on the test and transformations go out of your mind and you just don't remember how to do them, you can always revert to a table of values. We don't force you to graph it by the transformation. It's a good skill to have though. But you could always just plug in a bunch of X's and know what the general shape is and make sure you get a graph that matches that. But the transformations are quicker if you know them. So is everybody okay with that? All right, let's look at our last question, which someone asked about 16A. Let me go ahead and save that real quick before I go on. While that's saving, I'll read the directions. It says, if you have a graph of f of x, so we don't even care about graphing this one. They're just saying if you already have the graph, and this is what the function looked like, explain the transformations necessary to graph it. Okay, so we have to dissect the 3 things that are not just f of x. So notice there's a 2 out front, there's a negative inside here instead of just being a regular x, and there's a -5 at the end. The -5 at the end is a really easy one. That's a vertical shift. And anytime it's a vertical shift, you write exactly what you would think. So since it's negative, it's down 5. A negative inside the function, so inside the parent, means you reflect, but you reflect over the y-axis, not the x-axis. If the negative is out front, as in like B part, see how B has a negative out front of the F? That's when you reflect over the x-axis. And then if you have a number out front, there's 2 things you have to know. A number out front can fall into either one of 2 cases. If it has a negative out front too, that's not part of this, the negative would be a reflection. But if there's a number in front, if it's bigger than 1, it's called a stretch in the y direction. If the number is between 0 and 1, so it's a fraction essentially, it would be a compression in the y direction. So notice this one is a stretch, whereas this one right here is a compression. So when you actually write this out, because we want you to write it in a big old blank as a sentence, you need to do this as order of operations. If you write the transformations in the wrong order, I have to take off a partial credit point. So always work from the inside of f of x out. So this would be 1. I would multiply by 2 before subtracting 5 if I was doing order of operations. So this will be listed second, and this will be listed third. So my sentence would be g of x, because that's the new function we're trying to create, is f of x reflected over the y-axis stretched in the y direction by a factor of 2, because that's that number. You do need to reference that. And shifted down 5. And that is all you have to do. Now, if you don't write the exact same words that I do, it doesn't mean it's wrong. I'm just trying to be a little bit overzealous with my description. So this is my final answer for this. Is that one okay for everybody? Okay, so this is the end of the list of questions that you guys provided or I got through emails. I'll give you one more chance. Is there anything else we need to see? If you're good, if I've answered all your questions, you're free to go anytime that you want to step out. I just want to make sure I open it up since I have about 10 more minutes. I was planning on staying on tonight. Is there anything else that I can clarify for you guys? So for 15D, we need to do another parent graphing. This parent, though, is absolute value of x. So when you're plugging into this function, again, if you want to, you can get a table of values if you don't remember what the parent looks like. You plug in -1, 0, and 1, that would give you a 1, a 0, and a 1 because absolute value always goes back to being positive. So remember, this graph has a V shape, a nice sharp V. So in this case, the only thing different about this function is it has this number in front of the absolute value of x. If you have a number between 0 and 1 in front of the whole parent, remember that is a compression. And when we compress, we shrink the y values. How we do that is we take the y values and multiply them all by 1/5. Okay, so essentially this new chart would be -1, 1/5, 0, 0, because 0 times anything is still 0, and 1, 1/5. So what happened is that whatever comes out of this, it then gets multiplied by 1/5, so it's shrinking down that y value. So when you graph that, you'll notice that stretches or compressions just make things look wider or narrower. So if I wanted to plot this not parabola, this absolute value, here is 0, 0 would still be 0, 0, so that's still there. 1 and -1, though, both only go up to 1/5. So notice they're very short now. So my V looks like it's been squished vertically. It's like someone sat on it. So that is what a compression looks like. It looks like the thing has been squished down with a vertical bar. So just imagine somebody compressing it down. Is that one okay, Mariah? So if you had a 2 out front or a 3 or a 5 or some other number, you just take the y value and you multiply it by that. So you're always just taking this and either multiplying by whatever that factor is. And that gives you a new y value. And then from there, if there were extra transformations, you would use these 3 points as your starting point of where to go from there. So you'd always do this right after anything that happened inside. Is that okay for everybody? Okay. Unless nobody else has typed anything else, so unless you guys have anything else, you can sign off and I'll wait till everybody's done and then I will compress this video and save this as a PDF and then I'll get it posted for you guys. So if you want to watch again tomorrow or just revisit anything, you can have that there.